Hello, fellow YouTubers. Today we're going to look at balanced binary tree, which is LeetCode problem 110. This problem states that given a binary tree, determine if it is height balanced. For this problem, a height balanced binary tree is defined as a binary tree in which the left and right subtrees of every node differ in height by no more than 1. So if you look at example 1 here, you see that the 3 has a left branch and it also has a right branch which is longer, but if you take the right branch, which is length 2, and subtract the left branch of length 1, you get 1, and so it can differ by at least 1, or at the most 1. So this is true, but barely. And again, to read this, it's 3, 9, 20, and then the null is because the 9 has no left or right branch, then 15 and 7. Now example 2 is a no-go, because even though each of these nodes is differ by no more than 1, the distance from here to the 4 is definitely more than 1 than the distance from the 1 to the 2 here. So this one will be false. All right, let's see how we're going to do this. I question whether some of these, this is marked as easy, and I question whether it's an easy one, but anyway, more binary tree fun with recursion. So here is the method LeetCode gives us. So basically, if the root is null, we're going to return true. There's no reason the left and right are both empty, so as far as we're concerned, it's balanced. Then we're going to return the height. So we need to determine the height of the root. And to do this, we're going to compare the left to the right. And if when we run this method and it returns a -1, then that will return a false. Otherwise, anything that's not equal to -1 will return true. All right, so let's define this method. It's going to pass back an integer, and we'll pass in the node, the tree node. Okay, so if node is null, we're going to return 0. Meaning that the node, okay, so yeah, the node left or right, we're going to assign this to the left or right. So if it doesn't have a left or right, it's going to return 0. So int left equals, we're going to call height again, more recursion. But this time we're going to pass the node.left. And then we need to check the right value of the node too. So we're going to call height again and pass node.right. Now we're going to determine the distance between left and right. So we're going to do a math.abs, which is short for absolute, which basically means any number that's negative is just going to be returned as positive. So we're going to subtract left minus right. In the case where right is greater than left, it doesn't matter because we're doing absolute value. So if the distance is greater than 1, which was what LeetCode deemed as balanced, is if it's 1 or less, or if the left is equal to -1 or the right is equal to -1, then we're going to return -1, which will return false. Otherwise, we're going to return 1 for the current node plus the max of the math max of either the left or the right. And that is it. So let's run this through the debugger. Oh yeah, I got my handy chart here too. Okay, so we're going to take the first problem here. Basically, I recreated this tree, and now we're going to run through and figure out if it's balanced. Okay, so the first thing we're going to do is take the root. Now if you look here, the root node is 3. It's not false, so now we need to figure out the height. So we come down here, the node is not null, so now we need to determine the left node. So node left, now we're back in height but we're now using the value 9. And 9 does not have a left, and so we go to the right. 9 does not have a right either, so that returns null. Now we're going to close out the 9. We're going to take the distance between the left and right, which is just going to be 0 because it doesn't have left or right. And none of these are true, and so it's just going to return itself, basically 1 plus left and right. So that is what we got. Okay, so now we are on back to the 3, and we've done the left. Now we need to go on to the right. Okay, so now we have the 20. 20 has a node left, so now we're into the 15. It's not null, but the 15 doesn't have a left and it doesn't have a right. So now we're going to determine the distance between the left and the right, which is 0. None of those are true, and it returns 1. So this is now the value of the 20 has 1 left and its distance is 1. So now we'll go on to the right value, or the right branch of the 20. And so here we are with the 7. And the 7 doesn't have a left, doesn't have a right. So again, 0 for left minus right, absolute value. And distance is not greater than 1. Left and right are not equal to -1, so it will also pass left. Okay, so now we're back to the 20. And the 20 has a left of 1 and a right of 1. So we took the absolute value of that, and the distance is not greater than 1. Distance is 0. Math, so 1 plus left and right. All right, so now we're back to the 3. And we're going to the right. We finished off the right, so we have a distance of 2. The right has a distance of 2. The 20 to the 15 to the 7 is 2 away from the 3. But the left is 1 because we have the 9 branch. And so we're going to take 1 minus 2, which is -1, but absolute will make it 1. And so that is not greater than 1. And left and right are not equal to -1. And so we're going to return this. Actually, this really doesn't even matter because we're going to take the max of left and right plus 1, so it'll be 3. But all we're looking for is the Boolean, or that it, I'm sorry, the the integer. We're looking for the integer here. So this, as long as it's not equal to -1, it's going to return true. And that's exactly what it does. So this tree is balanced. All right, let's put it through LeetCode here. Run it with that first example. It is accepted, and then we run the code. Whoops. I need to run it twice just to be sure. Look at that. Again, fastest submission. All right, so let's go through the space and time complexity. So time complexity is O of n. Increase the number of nodes, it's going to increase the execution time to go through all those nodes. And then because I did the height balanced, determine if or make the tree height balanced in my last video, and that was log of n. But because the tree doesn't have to be height balanced, in this case we're checking for that, it's just O of n. And that is it. So as always, let me know if you have questions. Thanks for watching, and we'll see you next time.